Welcome to Pomodoro Joe for Friday, June 23rd, 2023. Today we're looking at LeetCode problem 1027, longest arithmetic subsequence. This is a medium problem. Now I don't have a lot of time today, so we're going to go through this one a little bit differently than usual. So in this one, we're given a list of integers, nums, and in that list we have a sequence of numbers. Our goal is to return the longest arithmetic subsequence in this list of nums. Now, we need to know a couple things. What is an arithmetic subsequence? And what is a subsequence? So a subsequence is just an array that can be derived from the original array by removing some elements, some or no elements. So essentially we're allowed to remove some elements, but we cannot reorder the elements in this array. So that's what a subsequence is. Now an arithmetic subsequence just means that the spacing, the difference between each element in our output array, in this case we're not actually outputting the array, we're just outputting its length, but each element in our subsequence, the delta between them will be the same. That is what an arithmetic subsequence is. So every element in, let's see, here's an example. We have 3, 6, 9, 12. So that's already an arithmetic subsequence because the difference between each element is 3. 3 to 6 is 3, 6 to 9 is 3, 9 to 12 is 3. So they can just return 4. Now in example 2, we can go 9, 4, 7, 2, 10, but the difference between these is not the same. So we have to choose some subset of these elements in that particular order. So let's see, what could we choose? Well, we can choose 4, 7, and 10 because 4 to 7 is 3 and 7 to 10 is also 3. So that is a length of 3. All right. So for this one, let's put 25 minutes on the Pomodoro timer and we will get started and we will go fast. So for this one, we will have some result. Now I can set the result to 2 because we can have at least 2 elements and their spacing will be, well, equal to their spacing. So I could set the result to 2 to begin with, and I can return that result at the end. Okay, now for this, we will be exercising our dynamic programming muscles here. So the idea here is we want to go through every element in our array. So we want to break this problem down into smaller problems. So with this one, we will be looking at an element and asking ourselves, what is the longest subsequence that ends at this element? In order to do that, we actually need to look at some previous element to figure out the delta between them. So we'll look at an element, we'll say, what's the longest subsequence of some specific delta that ends at this element? And we'll look back at some previous element and figure out what's the delta between these two elements. And for that previous element, what's the longest subsequence of that same delta that ends at that element? So we're going to keep some cache, some dynamic programming. So our DP will be a dictionary where the key will be the element that we're on and the, I guess, combined with the delta. That's not a very good way to describe this. Yeah, I'll describe it. Okay, the key will be the index into our nums array and the delta. So this will basically be saying, what is the longest subsequence with this delta that ends at this index? Maybe I'll call this end index. And the value will just be the length of that subsequence. Maybe I'll describe this a little bit better here. All right, so our end index is the index of the last element in the subsequence. Our delta is the spacing between each element in that subsequence. And those two things together are the key into our dynamic programming dictionary. And the value will just be that length. So our DP, for this, we'll have a default dictionary. Now, normally I would make this an integer. I will actually be making this with a default of 1 in this case, just because every time we have some key value pair, there's at least one element in that subsequence because it's the element itself. So for this, we can say lambda, which is a function, 1, it just returns 1. So for the default value, this will be 1. All right, Now we have to go through every element in our nums. So for every num in nums, or in this case we'll do index, so for every index in nums, our range length of nums. So we're going through every index in our input array, and we're going to grab that value. So we'll just say this value is equal to the value at nums. And in this case, I'm actually going to call this, instead of calling this I, we're going to be saying that this is the end index. This is the index where we're ending our subsequence. So I'm going to call this end index. So our value at the end index here. And now we need our delta. But our delta, we need to have another element to compare to. Like we need two elements to create a delta. So we actually have to go through every other, I guess, previous index. So I'll call this, well, I'll call it J for now. Okay, so we have our end index. We're saying how many subsequences end at this end index. Now we need to find some delta, which means we have to look for the previous value in our subsequence. So if we look at every previous index and essentially take this value minus the previous value, so our delta now, or maybe I'll do this, I'll call this previous val. So we only need to go up to our current index because we're only looking at values that came before our current index. So we'll go from 0 up to our end index, looking for previous values. Now the delta will be the difference between our current value, our end index, and this previous value. Okay, so now we have our end index and our previous value and our delta. Now what we need for our dp here, we need our end index, our delta, and the value that we get out of that. Okay, so at this point I'll need two keys into our dictionary, into our dp. One key will be where are we going to store this new value? So we'll be storing this new value at the new key for this end index. And then the other key we'll need is to look up, where do we look up the value of the previous value's subsequence with the same delta? So I'll have a lookup key. And that's a tuple with the previous value index or prev index and the delta. And then I'll have a storage key. This is where we store our new value. So that's going to be our end index and the delta. So this is where we'll find the longest subsequence that ends at this index with this delta. And this is where we'll store the longest subsequence that ends at this index with this delta. Now that we have our two keys, we can actually look up these values. So we can look at the previous subsequence, count, and that's just at our dp for the lookup. And again, if we don't have this lookup key in our dp, it will return 1, meaning this is the first element in a potential new subsequence. All right. And now we have our new subsequence count. And since we looked up the previous subsequence count, and we're adding this element at the end, it'll just be 1 plus the previous subsequence count. So we've added our new element, this end index, to the end of that subsequence. And now we can store that into our dp. Now I'm using a lot of extra variables here that aren't really necessary, but it's helpful in explaining how we do this problem. And finally down here, we can update our result. Now our result will always be the maximum of either the result that we already have or this new subsequence count. So I think this should just about do it. So we're going through every element in our input array and saying, this is going to be our end element. Now let's look back at all the elements that came before this consider that maybe the previous element and find out what's the delta between them. If we know the delta between them, then we can look up, well, what's the longest subsequence that ended at that element with the same delta? If we have one, we'll just add 1 to it because we've added this new element at the end of that subsequence, and we have a longer subsequence count. Then we store that in RDP for this new end index so that future end indices can look back and see this as an end index for some other subsequence. All right, and then we keep track of our longest result so far. Okay, so this should do it. Let's give it a shot. And we pass. Let's see if we can pass all of the tests. And we pass. We don't do great. We only beat 13% for runtime and 6% for memory, so it's not the best solution. I'll jump back really quick. I don't have a ton of time, but we'll try to do one thing super quick that will help us. So one thing we're doing here is we're going through every previous index, looking at the value, calculating the delta, and finding the longest subsequence that ended at that index. But one thing to realize is these indices, or the values at these indices, could be duplicate. There may be more than one of the same value. So if we had, let's say, what's an example? Do they have an example here? They don't. So if we had, for example, 2, 2, 2, 2, 2, 2, 2, 2, 2, 10. We're looking at 10, we go back to the first 2, that's a delta of 8. Then we're looking at 10 and we're going back to the second 2, that's a delta of 8 again. And so we are constantly looking at the same, I guess, subsequence ending at this subsequence index with the same delta, but with different indices. So if we can eliminate that and just look back at the values instead of indices, that will save us a ton of computation. So one thing we can do here is we can have previous values instead of previous indices, and we'll make this a set. So now, right here I'm going through all the indices. If we change this to values, actually it might be easier to, I'll just change this one, but you can do both this outside loop and this inside loop just looking at values, but I'll just change this one. So instead of looking at indices, we'll look at every start value or pre-value in our previous vals here. Make this plural. So every previous value in our previous vals. Now, instead of doing a lookup key on the index, we'll have to make a lookup key on the value. So that's one change we do need to make. So previous value and end value. I should have called this end val. Let's just do this. I might be making too many changes here. All right, and we do need to add our end value into our previous vals at the end here. So now we're just keeping track of the previous values and not necessarily their indices. But that's okay, because if we have duplicates, any one of them will do. I don't know if I can describe that very well. Let's just see if this works. All right. There we go, try that. Okay, that seems to work. Let's see if we do any better. And we do significantly better. So by changing just that one thing, we go from a 13% runtime and 6% memory all the way up to a 95% runtime and a 54% memory. So huge difference. All right. Well, that is it for me. I have to go. I'm totally out of time. Well, I hope you enjoyed this. Hope you had fun. I apologize for the rushed nature of this video, but hope you learned something anyway. Okay. Hope you learned something. Hope you had fun. Hope you can go out and write better code.